Hello everyone. In this video, let us learn fundamentals of mechanics. The first concept is, what is mechanics? What is mechanics? It is the branch of science which deals with study of forces and their effects on bodies which are in motion or which are at rest. Study of forces and their effects on bodies which are in motion or which are at rest. Then what is applied mechanics? Applied mechanics. Study of laws and principles of mechanics applied to solve engineering problems is known as applied mechanics. Study of laws and principles applied to solve engineering problems is known as applied mechanics. Applied mechanics is further divided into two groups, statics and dynamics. Statics and dynamics. Statics is a branch of applied mechanics which deals with bodies which are at rest, whereas dynamics is a branch of applied mechanics which deals with the bodies which are in motion. Dynamics is again subdivided into two groups, that is kinetics and kinematics. Kinetics and kinematics. Kinetics is a branch of dynamics which deals with bodies in motion considering mass and force causing motion, whereas kinematics is a branch of dynamics which deals with bodies in motion without considering mass and force causing motion. The next concept is difference between particle and body. Particle is a material point without dimension and contain definite amount of matter, whereas body is a portion of material limited in all directions. Body is a portion of material limited in all directions. After this, rigid body. Next concept is rigid body. It is the body in which particles remain in position even under the action of force. Suppose we have some object. If you apply some force on this body, okay, the distance between any two particles remains unchanged. Such a body is known as rigid body. After this, scalar and vector quantities. Scalar and vector quantities. This is very simple concept. We are studying this concept right from 8th standard. Therefore, we will discuss this in brief. Scalar is a physical quantity which has only magnitude, whereas vector is a physical quantity which has magnitude and direction. The example of scalar is mass, time. Example of vector, we can take force, velocity, acceleration, and so on. We can give as many examples. After this, fundamental and derived quantities. Fundamental and derived quantities. Fundamental and derived physical quantities. There are some of the physical quantities which can be measured independently, such as mass, time, length. Such physical quantities are known as fundamental quantities, and their units are known as fundamental units. Unit of mass is kg, unit of length is meters, and unit of time is second. These are SI units, of course. Then what are derived physical quantities? If the physical quantity is derived from two or more fundamental quantities, then it is known as derived physical quantity, and their units are known as derived units, like force, velocity, acceleration. All these are derived physical quantities because these are derived from two or more fundamental units. Then next is Newton's law of gravitation. Newton's law of gravitation. According to Newton's law of gravitation, every body attracts another body with a force which is directly proportional to product of masses and inversely proportional to square of the distance between them. Suppose we have two masses, m1 and m2. The center to center distance between these two masses is, say, r. According to Newton's law of gravitation, there exists always force of attraction between them, and this force of attraction is directly proportional to product of masses and inversely proportional to square of the distance between them. Therefore, F is equal to some proportionality constant, capital G. This is nothing but gravitational constant, m1 m2 upon r square. The value of this proportionality constant, that is gravitational constant, is 6.67 into 10 to the power minus 11. Its unit is Newton meter square upon kg square. Thanks for watching. Let's stop here. We will meet again in next video. Till then, goodbye.